Multiplication of algebraic expressions. To carry out the multiplication of algebraic expressions, we have to follow two simple rules. A. The product of two factors with like signs is positive and the product of two factors with unlike signs is negative. B. If x is a variable and m, n are positive integers, then x to the power m into x to the power n equals to x to the power m plus n. Thus, x to the power 3 into x to the power 5 equals to x to the power 3 plus 5 equals to x to the power 8. X to the power 6 plus x to the power 4 equals to x to the power 6 plus 4 equals to x to the power 10, etc. Multiplication of two or more monomials. Rule 1. Product of two monomials equals to product of their numerical coefficients into product of their variables parts. Example. Find the product of the following monomials. So A part is 3xy and minus 4x square y. So we have to find the product of the two monomials. So first of all, to find the product of 3xy and minus 4xy, we find the product of their coefficients 3 into minus 4 and the product of their variables multiplied by the product of their variables, that is xy into x square y. Now 3 into minus 4 gives minus 12 into xy into x square y gives x, and x to the power 1 into x to the power 2 gives x to the power 1 plus 2, and y to the power 1 plus 1, as there are y to the power 1 multiplied by y to the power 1. Y to the power 1 multiplied by y to the power 1 gives y to the power 1 plus 1. So we can write minus 12 x cube x to the power 3 minus 12 x to the power 3 and y to the power 2. So this is the product of the given two monomials, minus 12 x to the power 3 y to the power 2. So now let's see part B. Minus 5 by 2 ab multiplied by minus 2 by 7 a square b cube. Minus 5 by 2 multiplied by minus 2 by 7 into the product of their variables ab into a square b cube. Now we know that whenever two negative terms are multiplied, then the sign changes to positive. The multiplication of two like terms always gives a positive term, so we get plus 5 by 7 into here a to the power 1 into a to the power 2, that is a to the power 1 plus 2 powers get added, then b to the power 1 plus 3. So we get 5 by 7 a to the power 3 b to the power 4. So this is the product of the given two monomials. Multiplication of a polynomial by a monomial. Rule 2. Multiply each term of the polynomial by the monomial using the distributive law. A multiplied by b plus c equals to a multiplied by b plus a multiplied by c. Multiplication of two binomials. Consider two binomials a plus b and c plus d. To multiply a plus b and c plus d, we apply distributive property. A plus b multiplied by c plus d equals to a multiplied by c plus d plus b multiplied by c plus d equals to ac plus ad plus bc plus bd. This method is known as the horizontal method. Multiplication of a binomial by a trinomial. We may extend the above results for two polynomials as shown below. Example 1. Multiply 3x minus 2 by 2x square plus 3x minus 5. So first of all, we'll solve this by horizontal method. So by horizontal method, 3x minus 2, so this is our binomial, multiplied by our trinomial, that is 2x square plus 3x minus 5. In horizontal method, we multiply each term of the binomial with the complete trinomial. 3x multiplied by complete trinomial, 2x square plus 3x minus 5. Then our next term is minus 2. Then complete trinomial, 2x square plus 3x minus 5. 6x cube. Now 3x into plus 3x gives plus 9x square. Now 3x multiplied by minus 5 is minus 15x. Now multiplying minus 2 with 2x square, we get minus 4x square minus 4x square. Now minus 2 multiplied by plus 3x gives minus 6x. Minus 2 multiplied by minus 5 gives plus 10. Now when we solve the complete term, we add up the like terms, like 9x square and minus 4x square gives 5x square, 6x cube. Now so our x square terms are 9x square and minus 4x square, so we get plus 5x square. Now x terms are minus 15x minus 6x. So minus 15x minus 6x gives minus 21x, and the remaining constant, that is plus 10. So this is how we get our resultant of multiplying a binomial by a trinomial by horizontal method. Now we will see this by column method. So first we write our trinomial, 2x square plus 3x minus 5, and then our binomial, x minus 2. So first we multiply 3x by the complete trinomial. So 3x multiplied by 5 gives, and the same terms, that is x terms, will come in the same column, constants in same column, and x square terms in same column. So 3x multiplied by minus 5 gives minus 15x. Now 3x multiplied by plus 3x gives 9x square. So we have to maintain the column when we multiply the next term with the complete trinomial. So same terms to be written in the same column. So 3x multiplied by plus 2x square gives 6x cube. So this is plus 9x square, and now 3x multiplied by 2x square gives 6x cube. Now we will multiply minus 2 by the complete trinomial. So first we have multiply. Multiply by 3x. Now in the second step we will multiply by minus 2. So minus 2 into minus 5 gives plus 10. So this is the column for x term, x to the power 1. So we create a next column where we can write the constant, that is minus 2 into minus 5 gives plus 10. Now minus 2 into plus 3x gives minus 6x. Now minus 2 into plus 2x square gives minus 4x square. Here multiplied, we have multiplied by minus 2x. Here we have multiplied by minus 2. Now we have multiplied by 3x as well as by minus 2, that is by both the terms of the binomial. Now we will find the sum of the two. So adding them column wise, we get here only 10, so we write plus 10, as there is no above term to be added. Now adding the term x to the power 1, that is minus 15x plus minus 6x gives minus 21x. Now 9x square minus 4x square gives plus 5x square, and 6x cube as it is, as there is no other term in the column, so 6x cube. Hence our resultant after multiplication by column method is 6x cube plus 5x square minus 21x plus 10. We have done sum of the two, and hence we have get our resultant that is equal in both the methods.